So yeah, I'm Eric, and we're here today to talk about Drupal 8 and the Symfony event dispatcher. So what I'm going to go through today is just an overview of events, just so that we can all be on the same page, know what we're talking about, and then talk about using the Symfony event dispatcher for creating and dispatching events, and then also how do you respond to those events. And then the final part of the talk, we're going to be looking at the workflow of a request. So when Drupal gets a request from like the browser or from wherever, what are those kind of series of events, so to speak, that take place in order for Drupal to deliver a response. So to start off, this is a very boring textbook definition from Wikipedia. An event is an action that's occurred and it's handled by software. Kind of a bit boring. I prefer the dictionary explanation. So an event, thing that happens or takes place, especially one of importance. This is a big news flash. Lots of things happen in an application. Okay, when a page is requested, we might be doing some validation, saving some nodes, a user might have logged in, we're creating a session, all sorts of things are happening. And how do we know if they're an event or not? Well, we have the power to label something an event, right? Something that is important, we can say, this is an event. And the reason we do that is back to that first definition, right? So something has happened and something else might happen. And we can use events to help our application kind of communicate in terms of what's happened and what might happen because of the thing that's happened. Lots of things. I'm going to say the word thing a lot today. So we are familiar with this terminology, events. So we've all probably written some nice JavaScript in our time, you know, using jQuery to do a click event. These are all the kind of JavaScript events that we use in the browser. It's the same kind of terminology we're talking about here, in that something happens and something else happens. This is also something we're familiar with in terms of our kind of existing set. If you've come from Drupal 7 or even in Drupal 8, we've got hooks, we've got actions, we've got rules. These are all like things happened and something else happened. Rules itself defines itself as like I think the project page says it allows site administrators to define conditionally executed actions based on occurring events. So we know all of the events that we can see in the rules UI, and we can, you know, use that to create the actions. So where the event dispatcher comes in is the event dispatcher is part of the Symfony framework. So it's a component. It's required. It's in Drupal core. You don't need to download it or anything to get it. It's in the application, quite deep in the application, really. And what it does is it facilitates communication between your objects. So it translates essentially that something's happened to something might happen or is going to happen. It is an example of the mediator design pattern. So what that means is it's being in charge of the communication between your objects. It promotes the decoupling of your classes so that when one thing happens and something else happens, this thing doesn't need to know about this thing, because this thing might come from a module, it might come from a component, this thing might be your custom code, this thing might be someone else's custom code. To get those to talk to each other, it's basically saying we're going to use the event dispatcher to facilitate communication. It's going to mediate telling X that Y's happened. So if you think of it, well, if you look at it like this, let's say A is just something, some sort of class that's has a behavior on your website. When something happens, we're going to pass some data to the event dispatcher, and then that event dispatcher knows who else cares about that thing happening. So it's going to go forth and say, okay, B, this has happened, C, this has happened, and D, this has also happened. So to look at this in a far more practical way, I'm going to go through an example of something that we probably do quite often, which is building forms. So my super useful form, it's going to collect a name and an email address. When we have that name and email address, which is very valuable information to have, we're going to start doing a lot of things. We're going to log it, we're going to send an email to the user, we might add them to our CRM, we're going to, I don't know, call a Slack API and post it to our Slack channel so that we know that we have, more of people's data. And just to get completely crazy, because the further on you get into projects, often you get crazy requirements thrown in, we're going to calculate if the user gets a prize. I don't know what the prize would be, but hey, a competition to draw in people to give us your data. And this is just what we know at this point. So obviously in the future you could have more and more things happening once you have that valuable information of people's details. So if we get started from our first requirement, this is what we might do. We might say, okay, well, I just need to log this. My form, I've extended the form-based class, so I already have the logger object. That's fine. I'm just going to grab that and I am going to log this very helpful notice. Then we add sort of another thing. This time we want to send that email, so what we need to do is we need to have this mailer service that we can call in the submit handler. And we also need to know if we have a current user to get their language, to know what language we're sending the email in. And then of course if we're using these things in our form, we need to add them as dependencies to our form. So now our form, as well as the sort of base dependencies that the form class gives you, it's now got to know the current user and the mail sort of plugin manager. And then by the time we're kind of nearing the end of our project and we keep adding more and more functionality to that form, you see here that we're doing lots of things and we need lots of services. So after the mailer we've got our CRM and we're sending in some sort of parameters that our CRM service cares about. We need to know our Slack service and we need to know how to send messages to Slack. We're sending a message with the group name. And then our prize service that we again would probably need other services. We might need to create entities, all sorts of things. We're going to come up with some crazy logic to say, hey, if it's Monday and 29 minutes past the hour, you're going to be a winner. And that logic's probably going to get crazier and crazier. And so when we look at all of our dependencies, you can see it's getting quite big. We have all these things, to calculate the time to win a prize. We need the date time service. We need Slack, we need CRM, we need all these dependencies. Some of these, by the way, is just like pseudocode that I haven't bothered to see if there is a Slack service that does this, but shouldn't be too much to the point. So our dependency graph, if we're ignoring the ones that come with the form-based class, is we've got the form object and it needs all of these things just to be created, just to put out those two text fields that say name and email address. And for me this kind of represents a bit of a problem in our kind of architecture. Does everyone remember yesterday? Yes, cool. So yesterday we had like an awesome keynote and he was talking about the environment when he said personification is the most sustainable system. We can talk about our classes like this. You're weighing down this form with so many things to do. You're giving it so many things. And now your form class knows too many things. It knows the internals of how to construct a Slack message. It knows the internals of how you want to win a prize. All sorts of things that are just bundled into this submit handler. And that makes that form harder to use. You can't just extend it easily to, collect a name and email address and a phone number somewhere else on your site, because you're bringing through all of those dependencies that you need for this particular action. And it's harder to reuse if you say, have another purpose of this form and you want to just, collect that information again, or you've got all these things you might not have in your new context that you're using this form. So basically it's just doing too many things for my liking. It's giving me a bit of anxiety with how much we're asking it to do. So what we want to do is we want to change the slide. There we are. We want to go from this really, and we just want to smash those boundaries down, because my form doesn't need to know at this time who the current user is. It doesn't need to know about email. It doesn't need to know any of these things. These are all actions that happen after we've submitted the form. Yeah, okay, maybe logging, you can argue that's kind of intrinsic to a form. You can know about the logger. I'm happy with that. And we're going to kind of get to this stage by introducing the event dispatcher. Now this is not dependencies, this is simply like the line of communication, where we have our facilitator in the middle, and these objects don't need to know about each other, but they can all talk to each other essentially through the event dispatcher. So we're going to get started with that form and we're going to go through and we're going to dispatch an event and then we're going to listen to one. So let's dispatch an event, and this could be a choice you're making not just in something like this. You might have a module that's doing something quite important and you need to let other people know about that. It doesn't have to just be your own custom code you're trying to decouple. So yeah, let's get started. So the first thing we need to do when we're going to dispatch an event is we just need to think about what is that event. What information are we going to collect and allow to be communicated to other parts of the system, i.e. what thing has happened. And we need to say, should this information be changing? Can I allow other modules to change this data or to delete this data as they respond to the thing that's happened? And are we going to collect any additional information along the way? Like, do I want to know if something, has changed, or is there something that this thing is doing that I then need to, once it's been dispatched, see who's done something else? Too many things. So, step one, or step two, is some documentation. So, if you're from a Drupal 7 background, we used to have these mymodule.api PHP files to basically tell everyone about our hooks. Here we're going to just create a class that has the name of the event that we're going to send. So we are going to create a new event, which is called sign up form submit, and this is essentially the way it works. The event dispatcher is just going to pass a string. We're doing this so we have a constant to refer to, and then lots of other cool things can happen, like we can obviously trace this better. Console can kind of pick this up and know what our events are. The next thing we do is, after we've documented it and had our decisions about what our class is going to be, we create the event class, and the event class's purpose is going to carry that information between different parts of your system. So I've decided that my name and my email, that's not up for debate. You can't change that. That's come from the user. You can read it. I'm going to give you these public functions to get the name and get the email address, but I'm not going to let you, as another module, as another person, change that data. That's my data now. So yeah, the event class comes from Symfony, so we just extend that. It's got a couple of things that come with it that I'll talk about later on, and we just add our kind of properties that we're going to store with it. And so let's jump back to that form and remember what we were doing. We had all these dependencies. Well, now all we need to do is inject the event dispatcher. So we're going to get that from the container and add that to our form. And then when we go back to the submit form method, you see what we're going to do is from the form state, the same two lines we started with, we're going to grab the name and the email, and you can't see highlighting on this screen, but this the event new sign up form event, we're going to create this event that gets passed around, and we're putting in that data that we declared in the previous slide. And then all we need to do, all we need to do now is tell the event dispatcher to dispatch the event, and that is done through the dispatch method, which again, apologies, you can't see here. So here we dispatch the event. This is the name of the event that's happened, and obviously our data that we're telling everyone about. So that's cool. We're heading towards that. We're actually here. We've just got that one line of defense. One line of communication, which basically means we've gone from A to telling the event dispatcher about E, this event that we've created. But that's no good until we can complete that kind of line of communication by subscribing to an event. So how do we do that? When we're talking about subscribing to an event, we're basically saying, how does the Symfony event dispatcher know that these things on the other side of that graph, B, C, and D, how does it know that they care about this event? How does it know, who it should tell about this event? Well, again, those classes or those things need to tell the event dispatcher. They need to register themselves as subscribers of events. This is probably something that you're going to do a lot more often in Drupal 8 than you would creating and dispatching your own events, because there's all sorts of events we can subscribe to. So all this kind of centers around the event subscriber interface. This is like the contract that you kind of need to sign to say, I'm going to do this. And it's basically saying, I'm going to tell you what events I want to subscribe to. Perfect. Let's look at the example. So we're going to implement just that behavior around sending the user an email. So this is a new class we've created, a new service, and we're implementing the event subscriber interface, which means we have to say, oh, sorry, that's quite a bad size. We have to say here, this get subscribed events. What events does this particular service care about? This is what the event dispatcher is going to call to say, reach in and give me the events you care about, and I'll store those, and I'll come back to you when the event happens. So what we do is we return an array keyed by the event name. So this is the constant that we created before, and we're just going to pass an array of arrays, of a method name. So this is going to be used as a callable. So when the event happens, the event dispatcher has already, it already knows that we've subscribed to this event, so he's going to call this method. He's going to call on register, which is hidden down here at the bottom of the form. And we're obviously just up here injecting in those two services that we care about here, the current user and the mail interface. I can tell my voice is going to start breaking a lot now, so apologies. And then yeah, within that onRegister event, we just, that logic that we had in the form, we're now just putting it into the subscriber, and it's now just kind of nicely contained by itself. It's not right next to some CRM logic to distract you. If you need to care about the user email, you can go in there, you can look at it, and you don't have to say, what on earth is this crazy prize stuff you're doing below me? You can be focused if you need to read this or change this. Right, so how does the event dispatcher know what services it should ask for events? This is going to be the service definition of the service that as our listener or subscriber, which looks like, are we all kind of familiar with the basics of a service in Drupal and how we kind of register a service? Okay, I will take a detour then, since someone said no after this. But basically the important thing to look at for now is this tag here that says event subscriber. This is how the event dispatcher knows who is caring about events, and it can go out to those objects that are tagged, those services that are tagged with this, to say call that register event. So yes, you want to go on a detour. Let's go. So when I was talking about service, it's basically a PHP object that's performing a kind of global task. So the examples we've had, the current user service, that's like a proxy for the user. And then the mail service, that's the service that is in charge of sending your emails. When I talk about the service container, we're basically talking about another Symfony component that gives you a way of organizing and instantiating your objects and retrieving those fairly easily. It's kind of a lot to do with dependency injection. It's kind of made out to be quite a complicated thing. Dependency injection is pretty simple. You inject your dependencies. So not dependency injection, that is in your method, you're depending on the Slack client, you're manually creating it with whatever kind of services it needs, and then you are sending a message with it. Okay, that's not dependency injection because your dependencies are created within your class. Dependency injection is simply pushing that service into your class. So rather than creating that client yourself, you're just simply saying, hey, I know that there's a service that can do this, give it to me, I'm going to maybe store it on me for a bit, and then I can call it without having to worry about how do I create this, what does it depend on, how do I know, where this is coming from. And so that kind of raises the point is, well, where is it coming from then? Well, it comes from the service container. So that again is like a three-step process. You start with this YAML form, and I'm just going to wander over here. So this is the name of your service. So when I showed you that constructor before and it said container get current user, so that would be in the service definition file, basically this line here. Now the next thing that you see for each of these service definitions is the class. So this is your object that service is. And then when it gets really interesting is we have the arguments. So when a service depends on another service, you can refer to its name to get that. So rather than creating in this case the entity definition update manager, you need the entity manager for that. So if that's been created and you ask for the definition manager, the service container is going to say, right, I'll create this and I'll just push in this class I've already created, and here you go. You don't have to do the hard work of creating all this. So step one essentially is configuration. This is step two. It's just magic that happens. And then yeah, now when we in our YAML forms either say, give us the plugin manager, or perhaps in PHP we have the container itself and we say give me the plugin manager via this way. What happens is the service container has this like magical map of services and what they depend on, and if we just want to say, hey, I'm going to reach in here, give me B, it's going to say, cool, to have B you need E and D, I'm going to create those for you if they haven't been created already, I'm going to put them in D, put them in B, sorry, and here's B. You can play with that. Awesome. Yeah, here's a video of my cool form that I made. So we're going to add in my name and my email address, which you guys now collect as well. We submit that. We're going to jump into our debugger, and this is our submit function. So here you can see we've got the event that we're creating, which is those name and form from the form state. The event dispatcher, so yeah, this is still the event. The event dispatcher lives on the form. So if we look at the form, the class, we know, there we are, we've got this event dispatcher service, and we're just going to pass that event to it. Easy peasy. So when we jump through to the event dispatcher, it's going to come down here. You see it knows the event that we've submitted, and it's going to come down here and say, do we have any listeners for this? It's already been built. It already knows who's listening. These are all the events in our application. This is the one that we've sent, and these are the 4 listeners that we've built to decouple all that stuff from our form. So it's going to say, cool, I've got all these things that are listening to the sign-up event. These are the things I care about. And I'm just going to loop through each of those and call that callable that we gave it, that on-registration handler. So this bit here, yeah, it's just going to basically say execute this callback. When we do that, you can see here, this is that handler that we told it about, and this is where we're going to send the email. So, magic. We're kind of here already with this. You know, we have our form that's talking to the event dispatcher. We have our mailer that is being talked to by the event dispatcher, and we have all of our other kind of things that the event dispatcher is reaching out to and saying, hey, this happened. And the form doesn't have to know about any of it. So this is our lines of communication. This is kind of our dependency graph, in that we now have, you know, all of our things kind of floating in their own nice little space. So the form still depends on the event dispatcher, but the subscriber doesn't really depend on it. You know, you can still call that on register yourself if you have that event. So there's no real dependency there. And we have these like observer patterns where we've got these observer classes that care about the service. You can, of course, implement all your logic inside the subscriber itself. It doesn't have to be just this decorator that calls another service, like your prize picker. You could write all your logic in there and keep that together. But that's kind of where we've arrived at by decoupling. And why do I like this? Well, the single responsibility principle, you know, our objects are doing one thing, excuse me, they're doing one thing and they're doing it well. This makes maintenance a lot easier. We're following the open and closed principle, which is kind of, you know, a good way to keep our sites a bit more simple. If we want to change a behavior around what happens after the form is submitted, we don't need to then dig into that form to make any alterations. We can just, you know, alter our subscriber in its kind of own little bubble. There was a talk yesterday about high-performance teams, and one of the messages was build applications that are easy to accommodate small changes. Well, I don't want to send an email anymore, as in theory, quite a small change. Before this, you would have had to go onto the form, remove those dependencies, find the logic inside that submit handler and delete that. Now you can delete the service and delete the class. Easy. Run your tests, see that they fail, delete the tests. Much nicer than having to dig in and get distracted by crazy logic about forms and stuff like that. Why might this be bad? Well, it's loosely coupled, right? There are downsides to loose coupling. Like, the opposite of loose coupling in these tight systems is they have a lot of cohesion. It's quite, if you do want to read step by step what's happening, it is quite nice sometimes. So you kind of have that same kind of conflict in your head that was again talked about yesterday in the keynote around microservices. This is much more on a kind of micro level, but the same things about microservices in terms of like at what point do you split this out, you can apply that to this as well. At what point do you actually split these out into their own classes? What point do you say, okay, this is too much, this needs to be broken up and brought down into smaller chunks of logic? So, before we look at core, let's just go further with events. I didn't want to compare this to hooks too much, but I think comparisons are kind of inevitable. So we're going to look at two kind of differences between this and the hook system. So, we can prioritize events. So, if we remember this oh, where's my mouse gone? We remember this guy, how he said we're passing it an array of arrays. This is something that does give me anxiety. Can anyone tell me what is kind of weird and crazy about this? Well, maybe not crazy, but why might this make me anxious? I can't see hands, by the way, so someone can shout out.
Maybe it's the order of execution. Maybe you want one of these to fire after another one if there's a priority.
Yes, exactly. So remember with hooks we have like module implements alter, and we can kind of have a set definition about if this is going to run, make sure this runs after it. Okay, what this array is it's actually like, it's parameters, and when parameters are hidden, you often don't know that there is functionality there. So basically if we don't put in the second argument, we're basically saying, I don't really care when this runs, just give it a priority of 0. So we can't specifically order events, but we can prioritize them. So if I was going to give that a really nice big number like 1,000, that's how that array of listeners is sorted. It's sorted by the priority you give it. So if you give it a number of 1,000, you're basically saying, I'm a high priority event, put me at the top of the chain, I want to be executed first. Because this is an array, you can also quite easily just add your event twice. You can say, I want to run first-ish, so give me a high priority here, and I can attach that same array again to say, I also want to run last, just in case something's happened. But again, this is another thing. This number is another thing that gives me anxiety. It kind of reminds me of when I had to used to look at CSS and read other people's Z-index values and think, why the hell is this so large? Like, how can you be this important? Where did 1,000 come from? So yeah, we don't really have this like ordering, but we have priorities, and there are, I don't know, good and bad things about that, I guess. We can also do this. Stop the event. So you're an event, you're a subscriber, you're listening for an event, lots of other things are. When it gets to you and you've done your thing, you can say, stop listening to everyone else, I've done my job. And there are some quite cool use cases for that, which is what we are now going to look at. So, we've got to the part where we can talk about Drupal. Awesome. This is kind of like the typical thing that happens in Drupal when we get a request. Okay, we get a request that's received, we resolve the controller that's going to deliver that response and the arguments, we call the controller to get the output, and then that response is delivered to the browser. What's happening at kind of an event level is when we say we receive a request, so Symfony gives us a request object, and this is just collected from all your get, your post, your server variables. They're kind of bundled up into this nice request object that is given to the HttpKernel to say handle this request. So what happens is it handles the request. It says, hey, I have a request. Here's the request. You can listen to the request event. If someone listening to that request event says, I've got a response for this, here you go, it's going to shortcut this whole process and just go straight away, say, I have a response, here it is. Normally what's going to happen is people are going to respond to this event by just kind of like doing some bootstrapping things. So if you remember like hook init and hook boot and these kind of things, you can kind of chuck some information at that request object. So it's got a kind of a parameter bag of attributes that you can just throw some information to that request that you might need later on in your application. So we also have an event that's fired when it has the controller for your event. So if you've defined custom forms, you have a form controller that is the kind of the object that is building your form. You've got entity controllers that render entities. When it's found the controller that's applicable to this route, it fires this an event. And if you want to really cause some debugging headaches for your colleagues, you can replace a controller in this event. You can say, screw that controller, I'm going to put my own one in here. And everyone will think, why is that thing not handling this request? And we also have arguments that we pass to this controller. So for example, the entity controller, we pass them that it's node/1, so it knows that we're rendering node 1. We call the controller to get a response, and again, if we get a response object back, we just fire the response object and we deliver that. This is Drupal, so we don't get response objects back from our controllers. What we get back is render arrays often. So we have this additional process of, okay, who can transform this response into an actual response object? So this is where Drupal will say, okay, I know about render arrays. I have a rendering service. I'm going to turn this into a string of HTML to output that I can give to a response object. And then that event is fired, the response is delivered, the user sees it, and then we call this kernel terminate event. This is the user's already seen the page. We can terminate here to do anything. So again, if we think back to my form that I built, that's like a performance nightmare. We're calling so many APIs. What you probably want to do is queue that up, and then at the end of the request, when it's no longer going to be a factor for the user, you can call it again on the terminate. And then sometimes exceptions get thrown, and we can also handle those exceptions. So I kind of briefly mentioned that what gets passed around. When the kernel event gets passed around, we have access to the kernel, the request, and the request type. Where it gets interesting is that get response event. So that means that you can put a response into this event, which will call set the response object and stop propagation. And this is where Symfony will say, okay, cool, I've been provided with a response. I don't really need to care about the rest of this process. I'll deliver that. And when you combine that ability to stop propagation, because obviously if someone has said, I need to deliver a response for this, it's no point calling the other subscribers, because that's just wasted effort. So that kind of, along with the priorities, allows you to build this kind of chain of responsibility, where you're saying, hey, A, is this your thing? And he says no. And then you say, hey, B, is this your thing? And he says no. And you're like, hey, C, is this your thing? Do you care about this this particular thing? And then they can say, yes, here's the response for it. And then D and E, they don't get a shot. We don't care about them. They never get called, because we have a request already. How are we doing for time? 6 minutes. Cool. We can look at the request. So just like with our form, we kind of decoupled a lot of bits of behavior in our application and put them into separate things. A lot of the things that happen in Drupal, little tiny bits of functionality, are also kind of encapsulated into these event listeners. So when a request comes in, we can run these like little bits of behaviors. And again, we've got two things we're going to look at here. The redirect leading slashes subscriber, if you can guess what that does. If you put 2 slashes at the start of your URL, it will redirect you to the correct page. And the maintenance mode subscriber will, as you probably guess, give you the maintenance mode page if you're in maintenance mode. So the first one has a priority of 1,000, it gets called first, and then the next one gets called after it. So I've put my site into maintenance mode, and I'm going to go to // register interest. So what happens now? Again, that same process of that request object being passed into the kernel to handle. And then this is subscribing to the redirect event, and it says, cool, all right, here's the request object. We're going to get that from the event. And I'm going to check to see if you've started your URL with // because that's probably an issue. And I have, because I was being silly. So now it's going to say, okay, you really want to go here. Actually, no one says // as an actual URL. So it's going to set the response. So it passes in set response, which is going to stop propagation, which then means the request will be delivered to the browser, and anything else doesn't care. So now what we're seeing here is that we've already done the redirect. So now we're processing our second request, and it doesn't have 2 slashes. So then we go to the next kind of thing in the queue. We're going to the maintenance mode subscriber, which is going to say, hey, are you in maintenance mode? Yes, I am. Cool, here's the maintenance mode page. But because we have this sort of priority system, we didn't even check the last time if we were in maintenance mode. We still redirected, because who cares if we're in maintenance mode if we're just redirecting you to another page? So that's kind of like the pointer, well, not the point, but one of the really good things you can do in terms of prioritizing and stopping events. In another example here, we have a kernel exception. So exceptions can be thrown by the kernel if maybe you have a 404, it can't find the page. It's going to say, hey, it's content not found. Here's an exception. A few other use cases. So let's look at 404 pages. 2 kind of types of 404 pages in Drupal. We have the default exception HTML subscriber, which provides a HTML response, and then we have the fast 404s. So fast 404s, that's when you request, if you have it configured, you can have it so that if the user requests a page, or what appears to be a page, and it's not found, they're going to get this quite nice HTML view that can put more helpful information in there. If they request something like an asset that's probably going to be a system, they're going to see this, just this straight up, let's not waste time rendering, might not be a user. directly accessing this. And again, this is all done through listening to events. So we have this fast 404 subscriber. So he basically says, is fast 404 enabled? Is this request matched on this path? If it is, here's just like a quick string of HTML, and I'm going to set the response and give it back to you. Whereas the default exception listener is basically going to say, okay, I've got a 404. I know I've got a 404 page in Drupal. I'm going to do a sub request, so I'm going to request that page, get the HTML from the page I'm requesting, and then set that as the response for this other page. And here's a video of that. So we're going to hit this 404. We get to, again, handling the event. This time we'll just take another look at that dispatch. So here are our listeners. So you can see here we've got quite a few listeners for the kernel request. And this is our previous example of our leading redirect subscriber. And then we've also got the exception event. So the exception event contains this not found exception. And if we look at the subscribers for the exception event, you can see at the top here we have our fast 404 service, because this is at the top, because the whole point of this is so we don't have to waste time in Drupal rendering and checking things. So we can chuck that at the top. Whereas the HTML, we kind of want to do that as a last resort. So that's way down the bottom of the list. That's saying, hey, if no one else wants to handle this, I'll handle this. I'll render you an expensive page. So you can see on 404, cool, we've got the module enabled, so we've got it configured. But it's not a path that matches. So we're just going to send that through, and that's going to go on to the exception handler to say, give me an HTML page. Which again just has like a sub method for making that request. And then because it's doing a sub request, it kind of starts again from the request level again. But if we now go to the page and we add, .css or something, I think I did. I'll wait for myself. Yeah, .css. So now we're going to be requesting an asset, and this time when we send the request through and we listen for that on request event, this time the fast404 subscriber is going to say, hey, yes, this is my deal. I'm going to respond to this. Here is your string that you can send back. It's going to set that response, which is going to stop propagation, which means that we don't have to do any of the other stuff. All of that default subscriber is just, it's out of the picture because, hey, we've already handled the event. All right, let's have some lunch.